Hey everybody, Mr. Murray here, Mr. Murray's Mathland. Today we are talking about the classic slope. And specifically this video is finding the slope of a line given 2 points. So given two ordered pairs. First of all, what slope is? Slope is just another word for the rate of change of a line. In other words, if you have a line and as you look left to right, it's going up, that would be a positive rate of change. You think about if that were, money in your bank account's going up, that's positive. The slope would be the number that would measure how steeply it's going up. Is it going up kind of slowly, very slowly, or is it going up very steeply? That's what slope is. It measures how fast it's growing, how fast it's going up. Or likewise, if you have a line that is going down as you look left to right, that would be a negative rate of change. That would be a negative slope. And so we're going to talk about how to find that exact number, that slope. Okay, so the letter that is used to abbreviate slope is obviously M. Yeah, why would they use M for the word slope? It's not exactly known. Some people say that it might come from the French monter, which I think is to climb, if you think of it. And monter kind of sounds like mountain, and a mountain has a slope. So that could be true. I don't really know. But yeah, sure, works for me. So anyway, if you want to find the slope of a line, you need to know 2 points on that line. That's it. You need to know 2 points. And a point, the x-coordinate comes first, the y-coordinate comes second, right? So if I have 2 points, I can do the slope, but in the formula, just to distinguish here, we'll call the first point x1, y1, and the second point x2 and y2. Okay, so here's the formula for slope. You may remember it already, you may have learned it. It's a big fraction. It is y2 minus y1. So the difference between these two y-coordinates, y2 minus y1, divided by x2 minus x1. And that's it. And some people abbreviate this, you may see it in different forms. Some people abbreviate this as, the difference in y is often represented in math and science with a triangle. It's called the delta symbol. Difference in y over difference in x, or some people say change in y over change in x. Or as you look on a graph, the change in the y-coordinates measures how much you go up or down, right? The y-axis goes up and down, and the x is horizontal, right? So some people will say rise over run. That's more of a visual approach, which we'll look at in the other video. But these are all kinds of phrases that are associated with slope. We're going to focus on using this formula today and, not make any silly mistakes with it. Okay, so there's our little background here. And here's the first example we're going to do. Find the slope of a line passing through this pair of points. And, to start with, I'm just going to copy down that formula again. M, the slope, is equal to y2 minus y1 over x2 minus x1. And you're given 2 points, and a lot of people will say, well, which one is the first point and which one's the second point? Which one's y2, which one's y1? The answer is it doesn't really matter as long as you're consistent. So, for example, if you call this y2 because it's literally the second point, then that's fine. This has to be y1. And that means the x-coordinate that goes with that's x1, and this is x2. That's the thing. You have to keep x2 with y2 and x1 with y1. All right, so here is our slope for this line, y2 minus y1. So the y value, y2, is negative 1 minus y1, which is 5, negative 1 minus 5, over x2, and x2 is 4 minus x1, which is 13. And now you just have, you know, some subtraction here, but you have lots of negatives and tend to end up with stuff like that. So just be careful. Up top, -1 minus 5 is -6. And in the denominator, 4 minus 13, that's -9. And since you're often going to get fractions with slope, we're going to leave it as a fraction, but always in reduced form, right? So a negative divided by a negative is positive, and 6/9 reduces to 2/3, right? If you divide each of these by 3, you get positive 2/3. And there you go. That's your slope. Okay, let's just see a couple other examples because some, you know, some quirks can come up here doing these. Find the slope of this line passing through these 2 points. So again, just for practice and then, you know, repetition, I'm going to write the formula out. y2 minus y1 over x2 minus x1, right? And so my second y value is right here. This is x1, this is y1, this is x2, this is y2. So our slope is going to be y2, which is -9, minus y1. And y1 is a negative, so you're going to be doing minus and negative. So getting a double negative there, we'll handle that, but just be very careful. Over x2, which is -7, minus the other x value, x1, which is -8. And now let's combine those and be careful. -9 minus -4, so that's minus a negative. That is, it becomes a plus. -9 plus 4 is -5. And in the bottom, -7 minus -8, minus a negative again becomes plus. -7 plus 8 is +1. And here we go, we have a negative divided by a positive, so that's negative, and 5 divided by 1 is 5, right? We never leave anything over 1. That's not simplest form. So this slope is -5. Good, and a check you can do to make sure you haven't messed up the order is, for example, if this point right here, -7, -9, I'm just going to highlight that in yellow, and the other one I'm going to highlight in pink here. If you've done this right, then you should find that in your setup here, the coordinates from each point should be over top of each other. So what I mean by that is, see what I started my formula with -9 and -7 was in the bottom, right? The 2 points from the 2 coordinates from the same point, and then when I did minus the x and y values here, I had those same right there from the same point. So sometimes that's a nice check to see that, hey, these are from the same point, these are from the same point, so you didn't mess up the order. Okay, so 2 more examples here. Just because a couple other things you might run into. Hey, slope formula, y2 minus y1 over x2 minus x1. Doesn't hurt to say it, to write it every time until you just have it totally locked down. And this is x1, this is y1, this is x2, this is y2. So my formula is y2 minus y1, so 5 minus 5, over x2 minus x1. And up top here, now you get 5 minus 5 is 0, -8 minus 6, that's -14. Now when you have 0 in a fraction, we never leave 0 in a fraction because it means something's going on. What is 0 divided by -14? 0 divided by anything, as long as it's not 0, is always 0. And there you go. And if you don't believe me, you can always use your calculator to convince yourself 0 divided by -14 is in fact 0. And you might think that's kind of weird to have a 0 slope. So if you want to think about the graph, what kind of graph would have a 0 slope? It's whenever you get the same y coordinate that you're going to get 0 on top. And if I plot these points, 6, 5 would be roughly 6 to the right and 5 units up, right? I'll just do this to kind of sketch it. 6, 5. So there's that point, 6, 5. And the other point is -8, comma 5. So that would be 8 to the left and 5 units up. When you have the same y-coordinate, that means your graph is not going up or down as you go left to right. That is a horizontal line, and a horizontal line will always have a slope of 0. There's 0 change. It's like, if you think about your bank account and you just haven't made any deposits, hey, there's 0 change. Nothing's going in, nothing's coming out, staying the same. Okay, and last one here. These 2 points, again, here we go. Y2 minus y1 over x2 minus x1. And for these 2 points, this is x1, this is y1, this is x2, the second point, this is y2. So here we go. In the numerator, y2, which is negative 3, minus y1, which is 5, over x2, negative 2, minus x1, which is also negative 2. So we're seeing the similar thing to the last problem. Maybe you've already noticed. This time the x-coordinates were the same, but look what we get. Negative 3 minus 5 in the numerator is negative 8, and in the denominator, negative 2 minus negative 2. Minus negative is plus, and anything minus itself there is going to give you 0, right? Whenever you get x-coordinates that are the same, you're going to get 0 on the bottom. Now, what is negative 8 divided by 0? You cannot divide something by 0. It is undefined. It does not equal 0. So this is undefined. Or, you could use the sort of no solution, the null set symbol to show that it doesn't exist. And that's, either one of those things is okay. And again, if you get 0 in a fraction and you really, you're not sure, convince yourself with your old friend, the calculator. Try to divide by 0, and every calculator is different, but each one's going to give you some kind of error message, something like this, like, hey, this isn't possible, something's up here. And again, it doesn't hurt to start to make these connections that what kind of a line would have an undefined slope? That would be when your x-coordinates are the same, because that's what's going to make 0 on the bottom. Well, think about that. Think about what that looks like. Negative 2, 5. There would be that point. And the other one was negative 2 and negative 3. So again, a super rough sketch here, but that would be 2 to the left and 3 down, right? And when you draw that graph, what kind of line has the same x-coordinates? That's a vertical line. And you see that is an undefined slope, because if you think about it as being, your rate of change in your bank account, or riding your bike on it. Hey, I can ride my bike on a horizontal line. I can ride my bike up a hill. I can ride my bike down a hill. You can't ride your bike straight up a wall here. So that does not even have a slope at all. So we just say that that is undefined. Okay, so that's it. Tried to show you a little of everything: a positive slope, a negative slope, a 0 slope, and an undefined slope. So if you have any questions, feel free to let me know. Keep working hard.